Welcome back to Module 1 Part 2. Glad you're sticking with the course. Today we're going to talk about the slope-intercept form of a line. And in particular, after this lesson, we want you to understand slope as a change in y over change in x. We want you to recognize slope and y-intercept given a linear equation or a graph. We want you to be able to graph lines using the slope-intercept form and also write the equation of a slope in intercept form. Look at this funny little picture here, and you're going to see a gentleman here who's driving his car up and down a hill, and on the left side you'll notice that he's going down. On the right side he's going up. Both cases have slope. I've noticed in my experience with teaching mathematics that on the left side, if we use the definition rise over run, students don't always recognize this as a rise. They think it's a going down instead of a going up. And so because of that misconception that often creeps up in mathematics, I just like to stick with the definition of change in y over change in x for my definition of slope. And I'm going to give you a couple different slopes to think about. The first is a positive slope, and it's exactly the way it sounds. It's a line that goes upwards. And a negative slope would be a line that goes downwards. Now those are fairly easy for students to understand, but where we start to feel a bit mixed up is when we introduce this idea of no slope, or what we might call a zero slope.
So, Dr. Glaze, does that mean that if a car were on no slope, it wouldn't go anywhere?
Unless it had gas. And here's an example of a zero slope or no slope. I'm going to draw a horizontal line. And this point is negative 4, 4. And this point is 3, 4. Now using our definition of slope as change in y over change in x, I'll take this y value and subtract this y value from it. So 4 minus 4. And I'll take this x value and subtract this x values from it. So 3 minus a negative 4. And you'll notice that that gives me on top a 0 divided by 7. Well, 0 divided by anything is 0. So that's why a horizontal line we say has no slope, or zero slope. Now the undefined slope is the one that seems a little bit trickier for us. So I'm going to draw a vertical line here. And by definition, a vertical line has undefined slope. Now let's review why that would be. So I'll give myself a couple points here. And this is the point 2, 6. And this is the point 2, 4. And now when I apply the slope formula with that as well, I'll have the change in y, which is 6 minus 4, over a 2 minus 2, which is a 0. Sorry, that didn't look like a 2. There's a 2. So this gives me a 2 over a 0. And hopefully we've learned by now that you can't divide by 0. At least that's what Siri told me when I asked Siri last time. Now, let's give you an example of how to calculate a slope. This is just like a typical textbook problem. Here's a point 1, 2, and 4, 7. And the question would be, what's the slope between these 2 points? And so let's do it 2 ways. We're going to do one way, which is just to count it on the coordinate grid. Another way would be to use the formula. So if I'm going to count this doing a typical change in y over change in x, I know that I'm going up 1, 2, 3, 4, 5 units. And I'm going to the right 1, 2, 3 units. So that's going to give me a slope of 5/3. Now let's do this with our formula. The slope as we know it is given to us as y2 minus y1 over x2 minus x1. So this point, let's actually use these points here instead of writing the coordinates on the graph again. This is, I'm going to call this 7 my y2, so that's going to be a 7 minus a 2. And then here's my x2, which is a 4, minus my x1, which is a 1. 7 minus 2 is 5. 4 minus 1 is 3. So yes, my slope is 5/3. It comes out that way when I calculate it too. And oftentimes students will really worry about, well, which one of these do I call x1, y1 and x2, y2? Well, if you switch them around, you get the same answer. You know, as an example, if I called this value x2 and this value y2, and this value x1 and this one y1, you're going to get the same thing. It works out to where the signs, you end up having a negative on the numerator and the negative on the denominator, and a negative divided by a negative is a positive, so you get the same answer. Now, the y-intercept. Y-intercept is pretty straightforward. It's where we have a line that crosses the y-axis. So there's the y-intercept. Now sometimes the mix-up is somebody will say, well, isn't this the y-intercept? No, this is where we cross the x-axis. That's something else, and we'll be working with those intersections much later in this course, but just know for now it's where we cross the y-axis. Which brings us to the slope-intercept form. The slope-intercept form is super helpful when we know where we cross the y-axis and we know what the slope is. For example, we can say graph y equals 2x plus 3. So here's my y-intercept of 3. Here's my slope of 2. I go up 2 and over 1. And I'll do just a few extra points because it'll be easier for me to draw these. And it's fairly straightforward. We've been doing this type of graphing for a couple of years now. And we can turn around backwards and we can say, what's the equation for this line? So we see that the y-intercept is a negative. The last thing I want to cover before we end this video is a little bit of algebra manipulation. You're likely to see problems like this where we say, here's an equation, and this one happens to be in standard form, and we'd like you to put that into slope-intercept form. And we're going to do that by solving for y. That's just a fancy way of saying put y on one side of the equation. So I'll subtract 4x here. And I'll do it from each side. So that gives me a 3y is equal to negative 4x plus 15. And you ask, well, why did I put the negative 4x first? It's because it's a habit I'm in as a math person where the x's, or the slope portion of the equation, goes in front. And I'll divide the left side by 3, and I'll divide the right side by 3. Now remember, when you divide a polynomial by a number, or divide anything by a number, you divide everything in the numerator. So this is y equals negative 4/3 x plus 5. And now I've written this in slope-intercept form. Now why is this useful? Maybe you've been asked to graph something and you're more comfortable graphing this form as opposed to the standard form. And so now you've got a couple tools you can use to graph.